then Takahiro Sekikawa, Mark, Laura, Santiago, and then Peter. Each presenter will be given, you can ask them at the end. And we're hoping that we're going to have enough time for that, because at 2:30, at 14:30, we've got another session. So without wasting much of your time, I would like to call upon the first speaker from South Korea.
Good afternoon. My name is Moon. It's like changing of the title, but you can see my question there. Let's talk about this. I'm the board. I'm chairman. And I so far refuse the flushing toilet, which is 15 liters per flush. What's wrong with you? So first thing is that wasting too much water. So each time, certainly then if you make 100 times, then this one was if you make 100, and if you have 350 days, if you use 20 years, the lifetime usage is over 10,000 cubic of fresh drinking water. That is wrong. Second wrong is that in emergency, so if you go to Ebola area, can you go to toilet? Stop. Can you bring the toilet to you? Can you bring it to you? And in emergency, or also when you have an emergency, the real problem is water and toilet problem. And some ladies do not like this toilet. So this is the second problem on toilet. So the problem is that we mix urine and feces and send it to the water, and drinking water people worry about this one. So why you mix with water? Let's let them go to the soil. So this is the basic concept. The toilet and feces program has been there for whole history of life, whole history of human being. So somebody might have learned from some solution, learning from the past, especially the urine separation and fertilization is utilized in Asia, like Vietnam and Korea. So, for example, this is the urine toilet, which was developed 1,300 years ago in Korea. And they use it for toilet, they collect urine and use it for agriculture fertilizer. So this is the learning from the past. Based on this, I developed 3 new toilets like this. First, so why we have to use certain liters? Because we have to use the siphon, you should have used 13 or 8 or, but by changing the mechanism, by moving the pipe down and then you can go back. So with this, you can use only 4 liters for flushing, no pipe. It is on the market right now. Second is that toilet. So this is the paper toilet. You can use it. You can bring it to Ebola area. You can use your personal toilet, and you can use it for emergency. Like what is toilet? Third one is that this urine separation toilet. You sit in front here and this bag and this conveyor belt. Conveyor belt to move the feces to the back, urine to the front. You can separate it. You can use it for bioreactor. You can use it for other for fertilizer. So conclusion. So let's think differently about toilet. We need new paradigm of sanitation, and that we can find new technology. But before we find new technology, let's go back to the philosophy and wisdom from all people. Thank you very much.
Thank you very much, and that was a very short presentation, and at least according to the time allocated. So now I call upon the second presenter. Yeah, and you also have 5 minutes.
I came from Shizuoka, Japan. Mount Fuji is located in Shizuoka. Anyway, what is cryptosporidium? Cryptosporidium, a protozoan parasite, excreted in the feces of humans and animals worldwide. It causes the symptoms of cryptosporidiosis, including fever and vomiting and water diarrhea. Glycosporidum oocyst has a robust wall. The oocysts are resistant to normal water disinfection processes. So, the detection of Glycosporidum is important for drinking water quality control. There are many reports about the outbreak. The number of patients in Milwaukee, USA in 1993 was over 400,000. This is the life cycle of Glycosporidum. It consists shadowed in the feces and enter sewage farms. Depending on the types of sewage farms, some oocysts will be discharged into rivers. And the oocysts were resistant to hypochlorous acid, like this. So there is a possibility that we may ingest the oocyst from tap water. Glycosporidum testing in Japan. The official method by microscopy was announced in 2007. And gene diagnosis by real-time PCR and LAMP was added to the official method in 2012. This is the flow. Oocysts in a water sample are concentrated and purified using filtration and antibody-magnetic bead or centrifugation. The purified oocysts are identified by microscopy with fluorescent staining. Furthermore, they are used for gene diagnosis. This is the flow, the general method of Glycosporidum DNA RNA detection. Firstly, we extract DNA and RNA from the robust wall oocyst using freeze-thaw cycles, and a commercial kit consisting of protein and lysate buffer. In case that a lysate buffer contains a PCR inhibitor, we need to remove the PCR inhibitor using Shika. As for surfactant extraction treatment, SET, we incubate oocyst with 0.1% SDS without the purification process. But SDS is effectively extracting DNA, but is also a strong PCR inhibitor. So we need to add 5% to 20 as a suppressor of the inhibition. This is a set flow. It's very simple. Now I will show you image of the effect of surfactant on RT-PCR. This circle shows enzymes for RT-PCR. 320 is too weak to denature enzymes. But SDS inhibits RT-PCR because SDS denature the enzymes. And the suppression flow is hard to understand, so I'm explaining it using animation. Again, SDS inhibits RT-PCR, but 320 form the mixed micelle with SDS and recover the activity. And this is the conclusion. Consequently, we succeeded in detecting 18S rRNA extracted from 10 oocysts. Thank you for your attention.
Thank you very much, Takahiro. Again, questions will be asked at the end of the presentations. And now call upon Mark DeShoses from Duke University, Durham, USA.
All right, thank you. I'm leading a team, I'm Mark DeShoses. I'm leading a team from engineers and people doing life cycle assessment, both at Duke and University of Missouri. And what we're working on is an omni processor. The vision is shown here. The idea is a container that can accept the waste from different sources, fecal waste, either piped or through carriers, and treat it to clean water with a lot of reject heat. We're essentially doing supercritical water oxidation. It's burning in water. So how does it work? Essentially, it's a pressure cooker on steroids. It's very simple in concept. The challenge is to do it right and do the engineering correctly. Essentially, you bring your waste high pressure and high temperature, and within seconds, in the presence of air as an oxidant, everything is converted to CO2, and you get the combustion of heat. This is a picture of cement treated in our lab in the lab scale unit, and that's the effluent. Very clean water, no odor, just a few mineral salts, precipitate, everything, of course, is kept. This is the vision, the 3D vision. This is actual prototype in the 20-foot container. Again, this unit can treat the waste of about 1,200 people daily. It's a little dark, but here you see some heat exchangers and some of the characteristics of our system. It's actually a fairly small reactor. Again, the reaction is within a few seconds. The challenge is collecting the heat, and you see the heat exchanger here, high pressure separation in others. This is industrial equipment. We have stainless steel and Inconel because of corrosion. Here you see our sludge pump and control panels. Doug, you can see our postdocs working on this project. And just a quick picture here to show you that as you add more air, you get more oxidants, you're getting cleaner water, we have, of course, chemical characterization. I'm not showing those numbers here. As of about 10 days ago, we've reached supercritical conditions in our container unit, in our prototype. And these are temperature data, and you can see that as we're heating here, by the way, we're running with isopropanol as a test fuel for now. And just a low concentration, it burns really well. As we reach supercritical, we have ignition, reach very high temperatures, and then we have heat recovery. Our heat exchangers have an efficiency range of about 80 to 85%. So we're pretty happy about that. So we're very excited. We're up and running. Within a couple of weeks, we will be treating people sludge on campus, and so stay tuned for more results. What we're doing, we'll be doing beyond that is a lot of optimization studies, really characterizing system. As we do that, identifying what that means, and refine the business models that we have to better understand where and how this technology can fit. Of course, the challenge is being able to do that within the cost, and working on that. When we do that, we will be looking at maybe changing some parts of the design, maybe not, and hope to be in the field in 2016. And here is our contact and website and resource of funding. Thank you.
I would like to call upon Laura Kimani to give a presentation on the sanitary problem.
Good afternoon, everybody. Welcome to my presentation. It's my pleasure on behalf of my 200 teammates in Nairobi, Kenya, to share with you our work at Synergy. Synergy builds healthy, prosperous communities by providing accessible, affordable, and hygienic sanitation to urban slums. So how are we doing this? We have an innovative, system-based approach, and we are addressing the whole value chain of sanitation in 3 steps. First of all, we build and franchise those low-cost sanitation facilities to community members. Then collect. We provide a waste collection service, and our employees come every day and collect the waste and safely remove it from the community. And in the third step, we convert the waste into electricity and organic fertilizer. It all starts with this great product, our Fresh Life toilet. It's blue, it's bold, it's attractive and very functional. And each of our toilets has this friendly flashlight operator who welcomes you to pure poo. That's the way it looks from inside. It's very hygienic, easy to clean. We have a functional urine separation spot plate, which automatically separates urine and feces into two cartridges, which are further retained in our retention box to avoid any spillage into the environment. And here you see our employees. They come every day and collect the waste. They are provided with PPE. They have like fixed contracts with us. We train them and we provide them with health insurance. And then once the waste is removed from the community, we first use the hand carts, then we use actually trucks to bring them to our central processing plant, that's then further converted using thermophilic co-composting into fertilizer. We also look into diversifying our products. So one thing we're looking at is anaerobic digestion using this 10 cubic meter tube digester. We also look into further upscaling this now to a 100 cubic tube digester. We also look into producing biochar. This is like done through pyrolysis and an anaerobic condition. Biochar can be used to help to boost soil and water retention and nutrients. We also look into animal feed, and we are using this amazing fly larvae from the black soldier fly to degrade fecal waste, and then they're very rich, this larvae is very rich in protein. We harvest them and then turn it into animal feed. And lastly, we are also looking into nitrogen fertilizer, so nutrient recovery from urine. So currently we have 619 toilets serving 26,000 users every day. We collect daily 6 to 7 tons of feces and urine. And we want to scale up further. So I welcome everyone. We're looking for partners who help us to do so. Please contact me. We have a stand outside, or my colleague David. Thank you very much.
We now have a presentation from South Africa by Santiago.
Hello dear public. I'm Santiago Septién, and I will present you a laboratory work which is on the title Urology, Extrusion and Penetration of Fecal Sludge. This work was performed in the University of KwaZulu-Natal in the Polytron Research Group. Well, this project is funded by the Bill and Melinda Gates Foundation and is part of the Related on the Challenge. And in this challenge, the grantees require some information. So, urological properties of the fecal sludge. Why? Because to design pit empty augers like this, we can empty in a safe way the fecal sludge from the pits. And for processing, for example, for extrusion. Because, for example, there are dryers or convolution that needs the extrusion process to form pellets, and the presses will be processed easily. In our experimental study, we go to different toilets, pit latrines within the Etiquette municipality in Durban, South Africa, and we sampled fecal sludge from 8 different sections of the pits, from the front part at different aids, and from the back part also at different aids. After taking a sample of each section, we make measurements in the uriometer to measure the urological properties as viscosity, shear stress, and also we make some dynamic studies to know the viscoelasticity properties. And we couple this analysis with for each section, we measure the moisture and ash content to try to relate the urological properties with the composition of the fecal sludge. And additionally, we make penetrometer experiments to see if the fecal sludge is liquid or plastic. Well, the results is in the poster, so I don't have enough time to detail them, so I will go directly to the main findings. So the one of the more important findings is that the viscosity of the fecal sludge depends on the pit section, and this is related to in each peak section there is a different moisture and ash content. In fact, we realized that viscosity tends to increases or decreases, viscosity tends to decreases when we go deep in the pit latrine, because the fecal sludge is less wet and the ash content is higher. Second finding from the penetrometer experiments, we noticed that the fecal sludge has a very liquid behavior, much more liquid than plastic, which can be problematic, for example, for extrusion, because for extrusion we need fecal sludge which is quite plastic. So to increase the plasticity of fecal sludge, we added some sawdust under the fecal sludge and increased this property, and we improved this property. This is Leclo Telodomo from Lesotho. He's the student that makes all these experiments and these analyses. So we invite you to discuss in the poster in the later day. We can discuss, I will show you the details of this research. Thank you very much.
Thank you, Santiago. And finally, Peter also and Tui from Ghana. Is he here? Oh, you don't have it. Okay, looks like our colleague from Ghana is not here. So we are going to take advantage of the extra time that we have to now ask the questions that we may have on the presentations that have been made. And just to add that if you have any other additional questions, please, you can meet the presenters outside, by their posters. So just to give you a brief summary of what has been presented so far for some of the people who came later. The first presentation was made by Moyan Han from South Korea, and looked at the innovative solutions to sanitation. And the presentation argued that why should we spend or waste so much water, by mixing it with fecal waste, when we can actually separate them. So, and the presentation went on to suggest a number of solutions. And if you have any questions, I would urge you to ask the presenter about that later. And then the second presentation was about the importance of cryptosporidium testing, and this looked at a new testing method. And the third presentation was on a neighborhood scale treatment sewage system that has been developed in the US. And this is a containerized system that could be used in slums or in different places. And then we also had a presentation from Kenya by Sanage, which spoke about the work that they're doing in the slums in terms of solid waste management, ecological and sanitation, and how they're trying to create reused products from the West. And then finally we had the presentation from South Africa about the rheological properties of fecal sludge in Durban. So I think I would suggest that we only have 10 minutes. I would suggest that we quickly ask the presenters to come in front, I think, with chairs. You stand. Okay. I don't know whether the others are ready to stand. Okay, no problem. Oh yeah, okay. Yeah. First question. Do we have some microphone? We have microphone. Okay, there is one.
Thank you very much. My name is Christopher Kellner. I'm from Tanzania. I have a question to Mark. What is the energy balance of the system. I have a question to Laura. Tube digesters, are you aware that this is very sensitive? Did you also look in fixed dome or other technologies? And what are you planning to do with the gas?
Let me answer. We have 2 parts.
Let me finish my questions, and I have to 3 different people, 3 questions. And then to Santiago, you said you are mixing sawdust, and then you want soil, isn't it, as a fertilizer? Why going into the antibiotic effect of wood with sawdust and not with soil? Soil or night soil produces soil. That are my 3 questions.
Yeah, okay, I'll take the first one. So, 4,000 people, we have roughly 18 kilowatts on hand to run the system. I don't have the numbers yet because we haven't run the system with fecal sludge yet. But that's the goal. We do know that our heat exchangers are very efficient. We do know that the biggest power consumption is agriculture. So stay tuned. We'll know a lot more soon.
Yeah, thank you so much for your question. Why we decided to use a tube digester for the 10 cubic meter was because by that time, that was 2 years ago, and we were rather small. We had like 50 toilets, and we didn't know how much we scale up. And we already saw that before the scale up, we will have to move our treatment plant. So we wanted to have a movable system, not a permanent system. So that was one reason. And then also what you mean, like being not so stable. So we have it under a greenhouse and to keep the temperatures up. And we have really good results for that system. But I agree with you, like when we are looking now into upscaling, we actually also evaluate more permanent systems, like for example the fixed dome. Thank you.
Thank you for your question. In fact, I think maybe I make a mistake spelling, but it was I mean dry fecal sludge. Maybe I say so, I don't remember. But in fact, this is in the poster. We make some experiments. We compare the penetration of salt in fecal sludge alone, fecal sludge with sawdust, and fecal sludge with dry fecal sludge. And that's when we see that it's more plastic when we add these things. It's better for extrusion.
Okay, there's a question on there. Oh, sorry, before we go there, let's have that. Yeah.
Thank you, Sahabat Marcel, Indonesia. I have a question for the second speaker from Japan. Do you have any data about the number of occurrence per 1,000 people? The probability of happening of this cryptosporidium infection in several countries. I'm really interested if you have a data in developing countries. Thank you.
And I think before he answers, can we also have a second question? Okay, from here first, and then.
I'm Pitush from India. My question is to Laura. You said that the toilets are cleaned once in a day. So my question to you is that how do you take care of the odor problem in case of the subsequent users? The first user may not have the odor problem. But how do you take care of odor when the system has been used several times?
And last question for this round.
Hi, my name is Sasha Kramer from Soil and Navy, and my question is for Laura. We love Synergy, and my question is about your sawdust supply and how you maintain enough sawdust for all of your toilets.
Sorry, I couldn't catch your English because I'm not good at speaking English. So after this session, please ask me about it. Sorry.
Yeah, thanks a lot for these questions. I think the second question was kind of the answer to the first question. So how do we manage odor after the user? So we have like solace supplied in each of every toilet. And as I say, we have like an operator for each of those toilets and they educate the users. So after every dedication, people would pour sawdust on top of the waste. And that's how we like make sure that it's like fresh and that there's no flies and no smell. In terms of how do we make sure that we have so much sawdust throughout all of our toilets, so it's actually the obligation of the franchisee. So they sign with us a franchisee agreement where they commit that they always have sawdust at their toilets. So that means it's the responsibility of the operator of the toilet, and we only buy additional sawdust for the treatment and we do the co-composting. Thank you.
Okay, another round of questions. There's a question at the back.
Huyền Đắc from the National University of Civil Engineering, Vietnam. I have a question for Miss Professor Nguyen Han, okay, about the portable and movable toilets, I think, because it's made of paper, is it right? My first question, like, can it carry a big person, like maybe 120 kilograms? Can you tolerate it? And my second question is, usually after like using, people usually add lamp or soda or something just for sanitation. How about yours? Do you gonna add anything after use? Thank you.
Okay. Another question? Second question? No more questions? Oh, very good. Okay, go ahead.
Can you show my slide here? So, okay, it's like a book, this size, about 500 grams. When you use it and fold it, you sit down. So the design is about 300 kilograms.
300?
Okay, 5% of like you.
Okay.
So, it's portable, you can bring it in here. And also, you can use the plastic bag to use for fishes and urine. For urine, you need something to make some like a gel type, so that it does not move around. And also for fishes, you can make a plastic sheet using some biodegradable, and also we have to think about composition of fishes and so that to best composition of organic so that it can decay in 1 month or 2 months later on. So when you do like this, you can use the tent and you can bring your toilet anywhere and use it and unfold it and you can put it so the tank or container. After some time, you bring it to the some place and dispose of it. And without any further treatment, it will decay by itself. So that's my idea. I think it's very good for like Ebola infected areas or disaster areas where there's no water and they need the toilet.
Thank you.
And it's on the market now.
Any questions? Any other questions? We've actually been given a few extra minutes, so please feel free to put any extra questions. But there is a question at the back.
If it's on the market, how much does it cost?
Okay, any other questions before he answers?
If it's on the market, how much does it cost?
Cost.
Actually, nobody bought yet, so we are selling it to the government or disaster prevention department. They keep some sort of the toilet so that they can use it. So the problem is that it's not market driven. They need it when it shows time they need it also. So it's very hard to tell the price. But if you look at the cost of the material, only paper and some plastic material, plastic bag, so you can imagine that it may not be too expensive.
Okay, so but two questions now. Where's the microphone? we've been given up to 2:45, but we'll try to finish before then.
This question is for Sanerji. Also, really nice to see the presentation. A couple of questions. In some parts of Kenya, you've got landlords that own plots and tenants live on plots. I don't know if that's the case in Kibera where you work. If it is, I guess the question is, the toilet, do they tend to be public toilets or are they toilets on plots? How does that work with the franchisee? And the second one is, how much does a superstructure cost and who pays for it? And if it's the franchisee that pays it back, how long does it typically take them to repay?
Thank you very much. So first of all, I wanted to clarify, we are not in Kibera, we are in Mukuru. And yes, we have also landlords, but our model, most of our toilets are actually commercial toilets, so paid per use toilets. We have just recently started to move into household sanitation as well, but we realized we have to adapt our model a little bit. So potentially providing a bathroom and a shower to it, and we just further explore what would be the best option for households. And in terms of the price, so it's not only the toilet we are selling, we are franchising, and we have something we call the business in a box. So I didn't go very much into detail of that, but it means also training on health, like hygiene, marketing skills, business skills, and we offer them the basic supply, the startup kit they need. And then we provide continuously support to our FreshLife operators, because for Sanerji, the more successful the operator is, the better for Sanerji, because we get more base. So, and that's basically what you get when you buy the toilet.
All right, thank you. Maybe let me just give an opportunity to the speakers to say a word or two if they want, if they do have something to say, as in conclusion. Any?
So, as I said towards the end of my presentation, we believe very much in partnership. So we don't think Sanerji can do everything by ourselves. And again, please feel free to contact us. We really look into working with you, and please feel free and meet us outside. Thanks.
I'd like to repeat the same message for those people candidates. Okay, the sanitation program has been there for whole history of human being. So they might have some solution what 2,000 years ago, 10,000 years ago. Yes, it's good to make new technology, but we need to look at to our past, how they behave, how they treat to figure solution. So from that philosophy, we can add some technology that will be the solution for next generation. Thank you.
Thank you.
Very briefly, so if you have any questions, come and see me. We have openings on 2 different projects, so if you're postdocs with scales or interested, just come and see me.
If you have a question about bridging testing, especially in Japan, please ask afterwards.
Please come to see the poster.
Thank you, everybody, for